So hello again. This is Roger Kochbar. I'm here to talk for week 1 of the bioelectricity course on our segment number 5, lecture 5. This segment is about ions in solutions. So the question that we ask here is, in electricity in solutions, what is it that moves? Well, the answer is ions are what move. An ion, you might say, what is that? An ion is an atom or a molecule that's in the solution and that has a charge. And generally speaking, ions move around. So, for example, in water, an ordinary table salt molecule, sodium chloride, divides in the water into separate sodium and chloride ions. The sodium ion has a plus charge. The chloride ion has a negative charge. But sodium chloride doesn't have any net charge. So what's happening here is that when the division takes place, the sodium half gets an extra electron and the chloride half loses one. And as a result, you have two ions in the solution, each one with a charge. These ions are what give the solution conductivity. Just for interest, you might like to know that the name ion, which is derived from the Greek word that means going, was given to these things in the solution by Michael Faraday, the same person for whom the farad unit of capacitance is named. So it goes way back, the idea, and that is to say way back into the 1800s. It's newer than the origin of electricity, which was in the 1700s, much newer, but on the other hand, a long time ago from the perspective of the present day. Ions, incidentally, are invisible. So when you look in the solution, you can't tell if there are any ions in there or not. You have to test it electrically, and then you can find out by seeing the conductivity. Speaking of conductivity, it's a measure of how many and how easily charges move from place to place in the solution. So generally speaking, there are two factors. One is the concentration of ions, and of course, the more ions they are, the easier it is to move a certain number. The other factor is how easy it is for the ions that are there to move around in the particular solution. So those two things together determine the solution's conductivity. Within electrophysiology, the most important ions are sodium, potassium, and chloride. The reason for this is that the membrane itself looks for sodium ions, looks for potassium ions, and handles chloride as often accompanying either sodium or potassium. So it's, so to speak, built in. When you begin to talk about ions, an important subject is seawater. At first it seems unrelated, but then you can think back in an evolutionary sense or just a factual sense and observe that people and animals in their interior have solutions that in ionic sense are similar to seawater. So if you say, well, how about seawater? What's it like? So seawater has a resistivity of 25 ohm centimeters. Well, that's just an arbitrary unit, but it means that it's a fairly low resistivity, which means it can conduct quite well. Conductivity is the reciprocal, and it's measured in Siemens per centimeter, Siemens being the modern-day reciprocal unit of ohms. So this is just a note that says if you want to get the resistance of a cubical container filled with a solution of known resistivity, you multiply by the length and you divide by the cross-sectional area. Then that will give you the resistance of that container from the resistivity. That ends our discussion of ions. Thank you for watching. See you in the next segment.